I have been trying to figure out what input impedance is for about 6 months now, and I don't think anyone has explained it well enough, so here we go. NPN BJT tranny input impedance is caused because of the reversed bias base emitter junction, like the NPN diode. The reverse biased has high resistance, and impedance is frequency dependent. But since we're only dealing with DC, impedance is the same thing as resistance, so that high resistance from the diode, when reverse biased, is our impedance. Kind of looks like that. So until the base gets 0.7 volts above the emitter, there will not be any conduction. And the reverse bias of the collector to base is what gives us our output impedance, because there's no way that there's going to be any sort of flow into here. There is a path for things to flow down here, but that's just a little nifty. Okay, so at a minimum, the emitter will be at a point, or that's supposed to say base. The base will be at a 0.7 volt potential. Without an emitter resistor, oh no. The emitter will have a 0.7 volt voltage drop. Without an emitter resistor, the collector current will make your tranny explode due to dynamic resistance caused by the voltage from the base to the emitter, and the current on the base. You'll end up getting a very small resistance and the collector current going through there. The transistor is just not meant to handle that, so you have to make like a voltage divider, which is what the degenerative emitter resistor does. Without an emitter resistor, any voltage at the collector must drop through the emitter, dynamic resistance, the emitter bulk resistance, causing bad behavior. But now let's solve for everything. Oh no, where's the numbers? Ah, yes. We have our base voltage is going to be just 0.7 volts above our emitter voltage, and our base to emitter voltage is basically this VB right here. I have really just means 0.7 volts, but it's just written that way, but for a reason. The emitter voltage is using Ohm's law rewritten, the emitter current times the emitter resistance, and the emitter current is equal to the collector current plus the base current, and the collector current is the base current times beta. So the emitter current is the base current times beta plus the base current. Substitute that into this VE right here, or that IE right there. We'll get VE equals IB beta plus 1 times RE, and then substitute that VE into here. We get VBE is equal to VB plus IB beta plus 1 times RE. And then we substitute beta. Wait. CB equals VBE plus IB. Okay, so that's just sort of telling you that the input impedance is the base emitter voltage over the base current. So we have to get there. So we we substitute this V. That's what they're supposed to be VBE there. We substitute that. Or no, we just put this whole thing right into substitute that VBE for all of this information, and then you're able to divide out this IB, and VB equals IB times RB, which is right there. That gets you to cancel those out, and since your beta is so much larger than 1, you can get rid of the 1, and so you have your input impedance equals your base resistance that's in the transistor times the beta, or input resistance plus emitter resistance times beta, and since beta is collector current over base current, and the emitter resistance is emitter voltage over emitter current, and emitter current equals collector current, we can get input impedance equals the base resistance over the emitter voltage divided by the emitter current, which I switched to collector current so that I could switch out beta for the collector current over base current. So you have the input impedance equals the base resistance plus the emitter voltage over the base current. And finally, using 8 parameters and understanding that the input impedance is a ratio of voltage to current, and that the collector voltage actually drops as you increase the base current, and this is the H parameter for open circuit input resistance, and it equals the thermal voltage of 0.026 millivolts, which is negligible, so we get rid of that, and we end up with base, or input impedance is the voltage in the emitter over the base current. And how I had previously mentioned that why I used this VB right there, that would make that VBE if you really wanted to do that, but VBE doesn't change. VBE just stays 0.7, so I wanted to make sure that that you had a changing voltage for a changing current, and that they were algebraically related. There you go. That's that. That took me 6 months.